educational opportunities from the best institutions. So we believed education, and through education to empower human creativity is the only way that we as a society, as a race, can continue to evolve technologically. So it's this universal belief system really built the foundation of this company. So I do want to mention that we are a company from the Mars. But back to Earth, of course there are also a lot of exciting things for us as well of our age. There are those famous rovers around, right? There are transformers, as one of our students built with the Roboterra kits we saw here, and there are those Star Wars spacecraft-shaped robots. The Star Wars Force Awakens is now just hot in town, and then there are so many cute little droid inside as well. So it's this imagination being propelled and then stirred from those movies and then the animations. So as children, we all, once upon a time, dreamed that we want to have a robot. And with technological development of our society, now we already are in the mobile era. All kids, even as young as probably 18 months old, they started to react to touchable screens. They start to react about logic signals of the interfaces that we adults built. So this is the era we're talking about for younger generations' cognitive development. And governments, societies, companies working together to figure out what should be the best solutions to keep pushing forward education in this era of mobile technology and internet. So one example of what the US government has done is there is a federal policy to provide a lot of funding to introduce robotics as one of the main methods to promote STEM education, science, technology, engineering, and mathematics, which is very important, fundamental for modern economy's development. So first, stands for the inspiration and recognition of science technology. First is this nonprofit founded 30 years ago, almost my age, started to focus on introducing ideas about curriculums, training of teachers, guidelines of teachers training, and also, of course, how to connect the frontier research in robotics with the classroom level of learning and teaching of American schools. And under this mission, FIRST was founded, and one of the core founders is a great American inventor, the modern Edison, Mr. Dean Kamen, who is the inventor of Segway as well. So for FIRST, the way they push forward robotics into schools is by introducing open-end competitions in robotics for K-12. There are 3 levels of the FIRST robotic competitions. The youngest has been long-term sponsored by LEGO. So for children of 6 to 10 years old, the competition for them is called FLL, First Level League. And then for children after that age, basically higher grades of primary school and earlier in middle schools is FTC. That's also greatly supported by several major tech companies, LEGO's Pisco Branch, and also VEX. And then into the high school, more exciting, more combatively exciting robotics competition space is the FRC, First Robotic Competition. And these are one very typical regional competition of this annual competitions of high school level. So as you can see, the robots on the battlefield are significantly bigger than the one we have. So in that sense, a lot of schools, if they have one team, that means a group of 30 to 60 students got to work on one robot 1 year. So there's, of course, a lot of good schools with good experiences in history that they were able to make sure every student has a hands-on experience and master the techniques, and then in the end can contribute in the competition. But meanwhile, the more common situation is that so many schools and so many students at school or at schools, they never heard about robotics. They're also very interested and crazy about the fun learning and about science and technology. But there's no way for them to actually enjoy this fun. And for many of the existing common technology or robotics solutions, the programming part of it is still the color block, pull and drag based. Of course, it's a great invention by MIT on scratch programming, but that is also becoming a block on students' cognitive development because the real robots need the real programming skills as well, C programming, C++. So these are the real issues that our students and our schools are facing. They have a demand. We want to develop or provide robotics education on our campus. Or the parents, we want our kids to enjoy robotics education. And the kids, of course, they're crazy about robots, right? But there is just not a good enough solution yet. So this is how we, the team, Roboterra team, work together to where we are through many sleepless nights. Finally, robotics education made simple. And this is the team. Working together, we, in the past 2 years, we very fastly test out our prototypes and trying with different partner schools so that our partner schools can give us very good feedbacks that we can continuously improve the product and our users' experience in the end. So here, diagonally, you're actually seeing the 3 generations of our products in the past 2 years. Each one gave us great success and validated our model of the hardware and also our curriculum and content. And today, very proudly, together with my team at this year's CES, we are unveiling our newest Origin kit. It's this one in front of you, and then you can check out the details with all the essential parts for an educational robot. The think, sense, act, build, and connect part each corresponds back to the controller boards, the sensors, the connectors, and also the mechanical parts. And my co-founder and also our CTO, Chen, later on, he will go into details in the live demo about our kits. So mentioned all those great ideas behind our products. There's still one problem we need to solve. For the exciting students, when they're working on our robots or other kits, in groups or individually, there's still no way for us to know who is faster on programming, who can program very innovatively, who is just a genius on the mechanical structures, can always come up with great kinetical structures to support certain functions. So ability of reading and tracking students' learning patterns, cognitive patterns, and further develop an individual-based learning solution that we can advise to different students, or on the classroom level that teachers can know who is progressing on what basis and how they've been doing, so that to provide individualized feedbacks. Those, of course, can be very well addressed with the possibility that robots are actually computers with powerful sensors. They can collect and track students' learning